and welcome to our lesson today where we're going to study about segments, rays, parallel lines, and planes. In our last lesson we studied points, lines, and planes, and so we're going to be continuing that today. And we're going to start with a few definitions. First of all, a segment. A segment is a section of a line containing two endpoints and all of the points between them. In other words, a line has both a beginning and an ending point. When we name a line, we use a symbol that does not have arrows on the end. Remember, when we named a line, we used symbols with arrows. So a segment has a starting and a stopping point, so our symbol is going to look like this. We name a segment using the two endpoints. Unlike a line where we could use any 2 points on the line, a segment is very specific. You must find the two endpoints of the segment to name it. For example, segment AB and segment AC are not the same segment in this picture. If I wish to name the entire segment from one end to the other, I could name it segment AC, or I could name it segment CA, but I have to use the two endpoints. A ray is a section of a line that contains one endpoint and all of the points to one side of the endpoint. In other words, it has a definite beginning point, but it continues forever in the other direction. When we name a ray, we use a symbol with one arrow. The arrow must always face to the right, so our symbol looks like this. When we name a ray, we start by using the endpoint, and then any other point on the ray. For example, if I have a ray that looks like this, and let's call our endpoint F, if I wish to name the entire ray, I can name it ray FG, or I can name it ray FH. Either of these two rays is the same because they both start at F and they both go to the right and they go forever. I cannot switch the order around, however, and say ray GF because ray GF would indicate that I wanted to start at G and travel toward F toward the left. That would not be the same as FG. Opposite rays. Opposite rays are two collinear rays with the same endpoint that go in different directions. Remember, collinear means on the same line. So basically, they're two rays that have to have the same endpoint but go opposite directions. In other words, opposite rays always form a line. Opposite rays must start from the same endpoint. So if this is my endpoint of the first ray, it must also be my endpoint of the second ray, and it comes the opposite direction. If I named some points, I could say that FC and FP are opposite rays. Notice, both rays start at F. Opposite rays must have the same endpoint. One of them goes to the left and one of them goes to the right. So we're going to look at the following picture and answer each of these questions. First, it says to name all segments in the figure. In this figure, there should be 3 segments that we could name. There are 2 small segments and 1 larger segment. So first, segment RS or segment ST could be named in this figure. Remember, if I try to state these backwards, SR, that's the same thing, as well as TS. So I'm not going to name them the other way because they would be the exact same segment. My third segment is found by combining these two smaller segments together, and I have RT. Those are the three segments in this picture. Now I want to name the rays in this picture. If I start at R, there is actually only one ray that comes from point R, because from point R I cannot go to the left because there's nothing named over here. So from point R I can go to the right, and so I could say ray RS. If I tried to say ray RT, that would actually be the exact same ray, because ray RT would start at R and go toward T and keep going. It's the same thing as RS, so I'm not going to name that. Now I'm going to move to point S. At point S, I could go to both the left or the right. So there's a ray that starts at S and goes to the left toward R, or ray SR. I could also start at S and go to the right toward T, so I could have ST. Notice in my answers here that RS and SR are both listed because they are separate rays. One of them, RS, goes to the right, and the other, SR, goes to the left. Now we move to point T. At point T, I can go to the left and form a ray. So ray TS would be another possible ray. Ray TR would be the same thing, so these are the only four possible rays in this figure. Letter C says name a pair of opposite rays. Remember, to be opposite rays, they must start from the same endpoint and then go opposite directions. The only place where I can have two rays that come from the same endpoint but go opposite ways is if I start at S. So SR and ST are opposite rays. Letter D says to name the line in the figure. Remember, to name a line, you can use any 2 points on the line. So there are several names I could use. For example, I could call this line RT. Make sure you use the line symbol. I could also have named this line RS, or line SR, or line TR, or TS. There's several different names I could use. Letter E. Ray RS and ray SR form a line. Are they opposite rays? This can be a tricky question. These two rays do form a line. If I start at R and I go toward S, I go to the right. If I start at S and I go toward R, I go the other direction. Notice these two rays put together would form a line. But they are not opposite rays. Opposite rays must start from the same endpoint. The first ray starts at R and goes to the right, and the second ray starts at S and goes to the left, but they overlap each other. They do not have the same endpoint. In our next example, we're going to look at a picture that's very similar, but notice I have more points. In this picture, it says to name all the segments in the figure. An easy way to know how many segments you should name is by looking at the smaller segments. I can see that there are 3 smaller segments in this figure. If I add all the numbers below 3, that actually is how many segments are in this picture, or 6. Here's the reason. I first have 3 small segments in this picture that go from one point to the next point. So WX, XY, and YZ. That's 3 segments. Now I can name two segments that are a little larger and made up of two of the smaller segments. So WY and XZ. Our last segment is found by combining all three of the smaller segments together and naming that WZ. So there's our 6 segments in this figure. Letter B says to name all rays in the figure. Remember, when we name a ray, if it has the same endpoint and it goes the same direction, then it's not a different ray. So first, we could start with ray WX. Any other ray coming from W would have the same endpoint and go the same direction, so there are no other rays from W. From X, I could go to the left or to the right. If I went to the left, I could name this ray XW. If I went to the right, I could name it ray XY. There's no need to name ray XZ because that would be the same. Starting at Y, I can again go both directions, so YX is a ray and YZ is a ray. And then from my last point, I can go toward Y, so ZY, but any other ray starting at Z would be exactly the same. So those are the rays in this figure. Letter C, name a pair of opposite rays. For this, we need to find a pair of rays that start at the same point and go opposite directions. Our only choice is to start at X or to start at Y. For example, ray YX, which starts at Y and goes to the left, and ray YZ, which also starts at Y but goes to the right, are opposite rays. Letter D says to name the line in the figure. Remember, to name a line, you can use any 2 points on the line. So for example, I could call this line XY, as long as I use the symbol for a line. Our next definition is parallel lines. Normally when you ask somebody what parallel lines are, they'll tell you that they're lines that do not intersect. Although that is half true, there is more to that definition. Parallel lines are actually two lines in the same plane that never intersect. In other words, they have to run the same direction so that they can lie on the same flat surface. The reason that's important is because we also have something called skew lines. Skew lines are two lines in different planes that never intersect. Skew lines will always run different directions. For example, think about an overpass on a road. You might have one road that runs north and south, and then you have an overpass that goes over that road that runs east and west. Those roads do not intersect each other, but they don't run the same direction and they're not parallel. They run opposite directions and one runs above the other one. Those are what we call skew lines. Parallel planes are planes that never intersect. For example, think about the ceiling and the floor of a room. They're both flat surfaces and they don't actually intersect each other. So let's look at our last picture together. We have a picture of a box and we're asked to name all labeled segments parallel to segment AD. Remember, if they're parallel, any line segment that runs the same direction and does not intersect AD would be parallel to segment AD. So we have 3 segments in this picture that are parallel. Segment CB, segment HE, and segment FG. Notice FG, even though they're across from each other on the box, they run the same direction, which means they do lie in the same plane. The reason is I could connect those with a plane that runs diagonally. So they are indeed on the same plane parallel lines run the same direction. Our next example says to name a segment that is skew to AD. Remember, in order to be skew, the two lines run different directions and never intersect. So AD is on the top of the box and it runs from back to front. Segment EF is on the bottom of the box and runs left to right. Those two segments would never intersect. So EF is skew to AD. Letter C says to name a pair of parallel planes. Parallel planes are planes that don't intersect. For example, the top and the bottom of the box, or the left side and the right side of the box. So if I wish to name a pair of parallel planes, I might name plane ABC, or if I wish, I can name it plane ABCD, which is the top of the box, and plane EFGH, which is on the bottom of the box. Letter D, name another pair of parallel lines. So I don't want to use AD because that's what I used before. So if I want to name a pair of parallel lines, I might name something like AB and EF. Again, it says to name these as lines, so I use the line symbol. And our last example says to name another pair of skew lines. I want to use something other than segment AD. So another example might be something like segment BF, which runs up and down on the front of the box, and segment GH, which runs left to right on the back of the box. These two lines would never meet. I do want to make sure to name them as lines, so I put arrows on each end. So this is the end of today's lesson, and I'll see you in class tomorrow.